This video is dealing with a practical problem about three students who are sitting with a toy telephone and want to find the length of the string they will need to use that toy telephone. So let us see first. This is the question. See, let's read the question. A circular park of radius 20 meters is situated in a colony. Three boys, Ankur, Syed, and David, are sitting at equal distances on its boundary, each having a toy telephone in his hands to talk to each other. Find the length of the string of each phone. Okay, they are sitting at equal distance. They are having a toy telephone in their hands with a string attached to it. They have to find the length of the string of each phone. Okay, so if you try to visualize this, it will look like this. So this is how. There's Ankur sitting at one. This is a circular park. Radius is 20 meters. Ankur is sitting here. Syed is sitting here at this circumference, and David is sitting here with a circumference. They have a toy phone in their hand. So since are equally distanced, so this forms an equilateral triangle. So this means all three sides are of same length. Getting it? So this is how your situation is. This is a situation where we have to find what will be the length of the string which they are required to connect with each other. It's a toy telephone. They can talk to each other through this phone. Let us see the first. So this is your question. I have written the question again. Now, this is your solution. Now let us first see how to start with it. So what it is first, first method I am taking it's a trigonometric method. The first method, I'm solving this same sum by three different methods. Okay, so you should know that one particular method only, or you can solve it with different methods. So one first method which I'm taking is the trigonometric method. Now let us see. First, let us draw the figure. The figure will look like this. This is a circular park. This is a circular park. Ankur is sitting here because we have already visualized it. So I'm just writing it again. The Syed is sitting here and David is sitting here. They are at equal distance. So that means if you try to connect all these, they'll form an equilateral triangle. It will be like this. It forms an equilateral triangle. Okay. Now this is the center of the circular park. From the center, we draw a perpendicular. First, let us draw the radius. Center, join it to this, and then draw a perpendicular. Here, this is 90 degrees. Okay. So because this is 90, so if you take these two triangles, it will be congruent. I'll explain that above. So let us take this as M. So OM is perpendicular to SD. Okay. This is the radius. This is also radius. It is the same circle, so radius will be equal. Now these two circles, radius is how much? 20 meters. It is given here question. So, and let the length of the string from S to D be S. Now this is theta by, this angle will be theta by 2. Why it is theta by 2? Yes, here I am explaining it here. And this length will be S by 2. This total length is S. This will be S by 2. And this also will be S by 2. Let me explain this. How I have taken 3 by 2, theta by 2, and how I have taken S by 2 in each case. Now see here. First I am taking this triangle OMS and triangle OMD. So in triangle OMS and OMD, MS is equal to MD is equal to S by 2. It will be how? Why? Perpendicular from the center to the chord bisects the chord. That is the property I am using here. So here again I am repeating. Perpendicular from the center to the chord bisects the chord. That's why it is half of the total length S. So it is S by 2. Next, angle OMS and OMD both are equal to 90 degrees. Why it is? Because we have drawn them perpendicular. And OM is equal to OM. This is a common side to both this triangle. So this is equal to this. This is equal to both, and both are 90 degrees. Therefore, RHS rule, these two triangles are congruent. Clear? Because these two triangles are congruent, these two angles must be equal. So by SAS rule, these two triangles are congruent. Because these two triangles are congruent, each of these angles must be half of the total angle. Say total angle is theta, so this should be theta by 2. Clear? So when you are solving the problem, you need not write this portion. It is only for you to understand. That's why I have written in red. Don't write this figure and the further calculation. So now this is angle theta by 2, and we take this particular triangle. Now let us see. Three boys are sitting on the vertices of the equilateral triangle. Because they are sitting here and here, they are the vertices of the equilateral triangle, which is inscribed inside a circle. It is within the circle. Okay. The central angle between the adjacent boys. Now you see here, when you draw this line here, you get one triangle here, you get another triangle here, you get a third triangle here. So this angle plus this angle plus this angle total becomes 360 degrees. But they all are equal triangles. So it will be, each angle will be 360 divided by 3. It is 120 degrees. So that means this angle from here to here, angle SOD is 120 degrees. Clear? Because this angle plus this angle plus this angle total becomes 360. Now let us take the sine of angle theta by 2. Sine is what? Opposite by hypotenuse. What is opposite to this? S by 2. And what is the hypotenuse? Hypotenuse is nothing but your radius r. So sine theta by 2 is equal to S by 2 upon r. Let's put the value. Take r this side. We look at r sine theta by 2 is equal to S by 2. S by 2. Numerator is written in this form. Let us take 2 also this side. If you take 2 also this side, becomes S is equal to 2r sine theta by 2. Now let's put the values. 2r sine 120 divided by 2. 2r sine 60. What is sine 60? Root 3 by 2. Now puts the value of r. R, so 2 cancels. R is equal to root, so S is equal to r root 3. What is r? 20. 20 root 3. What is the value of root 3? 1.73. So 20 into 1.73, 34.6 meters. That is the length of the string you will require to connect each of the students. So the length of the string of each phone is 34.6 meters. Hope I am clear. So this was a trigonometric method. Now let us take the second method, which is analytical, and we use the concept of second one, using the concept of centroid. What is centroid? Let us draw that circle first. Ankur is sitting there. Sayyad, David. Form a equilateral triangle. Okay. What is a centroid? The point where the three medians of a triangle intersect is called as a centroid. That means you take the midpoint of the side and join it to the opposite vertex, you'll get what is called as a median. Take the midpoint, M is a midpoint, join it to the opposite vertex. So this particular line AM is called as a median. Okay. Similarly, you can take the midpoint of this side, L, join it to S. This is a second median. Take the midpoint of this side, or that is AS, say that is N, join it you'll get the third median. So all three medians pass through this point. This point, the point of intersection of the three medians, is called the centroid of the triangle. Now this centroid, because it's an equilateral triangle and it is inscribed inside the circle, therefore the centroid and the center of the circle both coincide. And centroid is always denoted by the letter G. Clear? So this is, and there's one property of the centroid, that centroid point G divides the median in the ratio 2:1. If this is 1, this will be 2. Okay, that is a thing. Now let us see. So R is 20 meters. So here what we have, segment, line segment AS is equal to line segment SD because it's an equilateral triangle, and it's also equal to line segment AD. All three line segments are equal, but they are the chords of this circle. So chord AS is equal to chord SD is equal to chord AD. All three chords are equal. So triangle ASD is an equilateral triangle. All three sides are equal. Therefore, it's an equilateral triangle. Centroid G of triangle ASD coincides with its circumcenter. So this coincides with the circumcenter. Therefore, this is the center also. It is the centroid also. Therefore, this length will be the radius of the circle. This also will be the radius of the circle, which is 20 meters. That means from here we are getting the radius. This is AG. This is the radius. SG is also radius. DG is also radius. And all are equal to 20 meters. Since G divides the median AM in the ratio 2:1. I told you the centroid divides the median in the ratio 2:1. That means AG upon GM should be 2/1. AG upon GM is 2/1. But AG is nothing but the radius, which is 20, and GM is, we have to find. So 20 upon GM is equal to 2/1. So GM will be 10. This implies that GM is 10 meters. So this is 10 meters. So now we take triangle GMS, this particular small triangle, and we use Pythagoras theorem here. Okay. So in this triangle, when you use Pythagoras theorem, this is the hypotenuse. So you know hypotenuse square is equal to this square plus this. So GS square is equal to GM square plus SM square. What is GS? GS is nothing but the radius, which is 20. GM, which we have just found, it is 10. And SM we have to find. SM. So SM will be, this 20 square is 400. 10 square is 100. Take it that way. So 400 minus 100, that's equal to square root of 300. That is 10 root 3. Okay. So SM is equal to SD. Now we want to find SD, not SM. SM is half of that because M is the midpoint. So SD is equal to twice SM. So 2 into 10 root 3 means 20 root 3. That is 20 into 1.73 is 34.6 meters. So the length of the string of each phone is 34.6 meters. So this was using the concept of centroid. Clear? This was another method of solving the same problem. See which method you wanted, because you got to think now. It is not that one particular, you take a book, one particular method is given and you just learn that and go ahead and write the exam. When you start learning on itself and you start thinking why not by other method, then you'll get an idea how to approach the problem. Now we are taking the third method. This is a third method. It is analytical, and here we are using Pythagoras theorem. Using Pythagoras theorem, we are trying to solve this. Again, let's draw the figure. Ankur, Syed, David. Equilateral triangle. Okay, we are going to use Pythagoras theorem. So let us take the midpoint and join. So let us draw the median. Midpoint, join. So in an equilateral triangle, when you take the midpoint and join, this will be a right angle here. Why? Because this side is equal to this side. This is common. Okay. And M is a midpoint. Therefore, this is equal to this. So these two triangles will be congruent. Because these two triangles are congruent, these two angles will be equal. That means both will be 90. So you can use Pythagoras theorem for this triangle. That's why we are telling using Pythagoras theorem. Now, I can draw one more median, the third median. As I told you, this is the point G, but it's also equal to center. So let us take it as O, center of the circle. So now if you take this, let us first take the bigger triangle. This is R, this is R, this is R. All are radius. OA, OS and OD all are radius and it's equal to 20. And let this be A. Okay, length of side SD is A. So that means this is a midpoint, therefore it should be A by 2. This also should be A by 2. So chord AS is equal to chord SD is equal to chord AD is equal to A. All are A. In triangle AMS, let's use Pythagoras theorem. Here the hypotenuse is this AS. AS is equal to AM square plus SM square. Let's put the value. A S A because all sides are A, therefore A square is equal to AM square plus SM. SM is A by 2. So A by 2 whole square. So AM square is equal to A square. This quantity, take it to that side, become minus A by 2 whole square. What will become? A square minus A square by 4. Let us take LCM. 4A square minus A square upon 4. So 4A square minus A square is 3A square upon 4. So 3A square upon 4. If you take the square root, because there is AM square, so if you take square root, so A will come outside the root sign, 3 will be inside the root, and square root of 4 is 2. So AM, this full length is A root 3 by 2. Okay, now let's want to focus on this small triangle. Okay, so let us take this particular triangle. So before that, I want to find OM. Now, OM is equal to AM minus AO. AM minus AO. AM is A root 3 by 2 and AO is the radius which is equal to 20. This is your OM. Okay. Now we apply Pythagoras theorem to this particular triangle OMS, this small triangle here. OS is a radius, so and it is a hypotenuse. OS square is equal to SM square plus OM square. So OS is 20. 20 square is equal to SM. SM is A by 2. A by 2 whole square plus OM. OM is just what is it? A root 3 by 2 minus 20 whole square. So we use A minus B whole square. A square minus 2AB plus B square. That identity to be used here. I'm not writing that identity, but I hope you will know that. 20 square is 400. 400. A square upon 4. This square is 3A square by 4 minus 2AB. 2 into this into this. 2 cancels. 20A root 3. 20A root 3. Again plus 20 square is 400. 400 cancels. When you take this 400, this side becomes 0. So 0 is equal to this, both are having the same denominator, LCM, it will be 3A square plus A square will be 4A square minus 20 A root 3. So 4A square upon 4 minus 20 A root 3. 4 cancels. So only A square will remain. So you take this one, this side become A square is equal to 20 A root 3. Okay, divide both sides by a, it will become only a. A is equal to 20 root 3, that equal 20 into 1.73, that is 34.6. So the length of the string of each phone is 34.6 meters. This was your Pythagoras theorem. Clear? Hope you understood the three methods of solving the same sum. I just putting this so that you should know that it is not only one method, I can use different methods. So there is nothing called one in mathematics. We can solve the same sum in different methods. One method is not fixed, that it is the only method possible. No, there is nothing like that. That's why. Okay, you hope you've understood and enjoyed the video. Thank you for watching it. If you are liking it, please like the video and subscribe for this channel if you are for the first time, and share it with your friends so that they also could benefit. Okay, that's fine.